a quick video on introduction to load balancers. What is a load balancer? Well, essentially it's a device which channels traffic across different servers. So it takes incoming traffic and distributes it across a number of servers. Now, before we go into depth about why we need a load balancer or what is it, let's take a look at a basic web session. So here we have a client machine at the top. In the middle, we have a cloud which represents the internet, and then we have a server at the bottom. Let's say the client wants to access a website, example.com, which is hosted by the server. The client sends in the request, which is routed by the internet, and the request reaches the server, which predictably serves example.com. Now let's step it up a bit. Imagine there are lots of clients, millions of clients trying to connect to this one server. Well, they send in a lot of requests, which is a lot of load for the server, and no prices for guessing that the server has lots of problems. So why did the server have problems? Well, first of all, it has limited number of resources like memory, CPU, disk space, so on and so forth. How do we solve these problems? One of the easiest ways or most logical ways is to add more servers. Okay, so let's add a couple of more servers. Let's add 2 more servers. Since we've added more servers, we need a device which polices incoming connections to these servers. Enter the load balancer. Now, all the incoming connections, which was a lot of them, hit the load balancer, which then distributes it across these servers. The way this distribution is done depends on various algorithms. One of the simplest one is round robin. So each incoming request is sent to the first server, then the next one is sent to the second server, the third server, the fourth request is sent back to the first server, so on and so forth. This is one of the many algorithms which determine where traffic is routed. Aside from this, the load balancer also maintains a health check on each of these servers. If one of the servers was to fail the health check, the load balancer would stop sending traffic to that particular server. Okay, moving on. So how does all of this work? Essentially, what the clients were hitting was a virtual IP. So a load balancer is configured with an IP address which acts as the virtual IP for the load balancer. And for all the clients, this is the place where they connect to. This is a virtual server for them. They don't see this real servers behind the load balancer, but they could connect to this virtual IP. This virtual IP is then traffic is then reverse proxied from this IP to the real servers on the back end. The real servers form what is called a server pool. So this is essentially how load balancing works. Moving on, why do we need load balancers? Well, first and foremost, it's pretty obvious, minimize downtime. Let's say one of the servers in our pool has gone down, or maybe you want to do some maintenance on it, like update the OS, put in some patches, whatnot. So if one server goes down, well, no problem. We still have other 2 servers running, and the load balancer routes the incoming traffic to those 2 servers. It will continue doing that until server 1 comes back up. Second reason why we need load balancers is high scalability. Load balancers allow you to scale your network and advance your network and resources as you go along. Like in the previous example, we had 3 servers. Say you want to add 2 more servers to this pool. Well, pretty easy. Under the same VIP, the black one on the left, we add 2 more servers to the existing pool. So it makes our job very easy. Everything is already pre-configured. We just add 2 more servers to the pool, and voila, we're good to go. Let's say the devs come up with a new application and they need new servers with new VIPs. Pretty easy. The load balancer, we just go there, we create a new VIP, configure it with a new pool of servers which cater to this VIP for the new application. So as you can see, load balancers offer a very good solution towards high scalability. They also offer advanced features like global server load balancing, but they're beyond the scope of this video. Finally, next-gen features. So load balancers have come a long way forward from just balancing traffic across different servers. Now they offer things like optimization, which includes techniques like TCP connection reuse, or acceleration, which includes techniques like caching. So contents from the backend real servers are cached on the load balancers and then served to the clients. This means that the processing time on the server is lesser and the clients receive a good response time. Also, this offers customization. So since the load balancer sits in the middle of the client and the server, it looks at the incoming client requests, and which allows us to write certain scripts to direct traffic in the way that we want it to. So there you go, guys. That's a basic introduction to load balancers. I hope you guys enjoyed this video, and hopefully I'll be making more.